We're going to solve this equation, x minus 19 equals 34. We're going to solve this for x. We're going to find the value of x. To do that, you have to isolate the variable, isolate the x, get the x by itself. And to do that, you have to move the 19 to the other side. So to move that 19 to the other side, you have to do the opposite of what's going on right now. It's subtracting 19, so the opposite of subtracting, of course, is adding. We're going to add 19 to each side. If you add 19 to each side, on the left side, that's what's important. The 19 and the negative 19, those cancel each other out. You're left with x. That's what you want to have happen, is you want to get the x by itself. On the right side, 34 plus 19, that is 53. But we want to check that, make sure we do have the correct solution. And to do that, you need to substitute the 53 back in for x. So that's saying x is 53. To make sure, put 53 back in for x, and we should get a true statement. Both sides should equal each other. If you put 53 back in for x, we end up with 53 minus 19 equals 34. And 53 minus 19 is 34. So we get 34 equals 34, a true statement. When you substitute the value of the variable back in, both sides equal each other. That means you do have the correct solution. X does equal 53. We're going to solve negative y equals 8. We're going to solve this for y. We need to get the y by itself. Notice there's a negative sign in front of the y. So we have to move that negative sign to the other side. To move that negative sign to the other side, again, we're thinking do the opposite of what's going on right now. You have a negative sign multiplied, it looks like, by y, but you can think of it as negative 1 times y. So to undo that, do the opposite of that, divide each side by negative 1. If you divide each side by negative 1, notice negative y divided by negative 1, that is positive y. And on the right, 8 divided by negative 1 is negative 8. Another way you could have handled that is to multiply both sides by negative 1, and you would still end up with the same thing. You would have y equals negative 8. Still, we want to check that, make sure we do have the correct solution. Substitute negative 8 back in for y. Watch this negative sign. When you substitute negative 8 back in for y, don't forget it's the negative of y. So it would be the negative of a negative 8 equals 8. And two negative signs back to back, that makes a positive. 8 equals 8. So we got a true statement. And that means we do have the correct solution, y equals negative 8. To solve this equation, 5x minus 3 equals negative 33. We want to solve this for x, get the x by itself. So we have two things to do. You have to move the negative 3 to the other side, and we have to move that 5 to the other side. So to undo those, do the opposite of what's going on right now. Right now it's subtracting 3, so to undo that, add 3 to both sides. If you add 3 to each side, we end up with 5x equals negative 30. Now we have 5 times x. So you have to undo that 5. Do the opposite of what's going on right now, and that is to divide each side by 5. Whatever you do to one side, you have to do to the other side. So if you divide the left side by 5, you have to divide the right side by 5 as well. We end up with x equals negative 6. But still, we want to check that and make sure we do have the correct solution. Substitute that negative 6 back in for x. So if you substitute negative 6 back in for x, you have 5 times negative 6 minus 3 equals negative 33. Watch your signs. 5 times negative 6 is negative 30. And negative 30 minus 3, that is negative 33. Both sides equal each other. We do have the correct solution. When you substitute the value of the variable back in and you get a true statement where both sides equal each other, you do have the correct solution. 7y minus 2y plus 4 plus 3y equals negative 20. We're going to solve this for y. You need to get the y by itself, but you might think, well, there's plenty of y's there. Yes, there is. You need to combine those y's. Get all those y's together. Take 7y minus 2y plus 3y. So you're just taking 7 minus 2 plus 3 and then attaching a y to it. So 7y minus 2y, it's 5y, and 5y plus 3y, that is 8y. Don't forget your 4. Now we have 8y plus 4 equals negative 20. So again, we have two things to do here. You need to move the 4 to the other side, and then you also have to move the 8 to the other side. So to move that 4 to the other side, do the opposite of what's going on right now. It's adding 4, subtract 4 from each side. If you subtract 4 from each side, we end up with 8y on the left equals negative 24. Now you have to move the 8 to the other side. Do the opposite of what's taking place right now. It's 8 times y. The opposite of multiplication is, of course, division. Divide each side by 8. If you divide each side by 8, 8y divided by 8 on the left side, that's important that you get y by itself. On the right side, negative 24 divided by 8 is negative 3. But still, you want to check that, make sure you do have the correct solution. Substitute negative 3 back into the original equation for y. So we're replacing all of the y's in that original equation with negative 3. So we have 7 times negative 3, that'll be negative 21. Negative 2 times negative 3, watch your signs, that's a positive 6. Still have that 4. And then 3 times negative 3, that will be negative 9. On the left side, combine those, negative 21 plus 6 plus 4 minus 9. I'm guessing that's going to be negative 20, and it is. Negative 20 equals negative 20. Both sides equal each other. That means you do have the correct solution. When you substitute the value back in, you should get a true statement where both sides equal each other, meaning you do have the correct solution. Y equals negative 3.